Hi, everyone. Welcome back to section 1.6. We are going over solving rational equations in this case. We'll begin by identifying that 12 was the LCD of 3, 2, 4, and 2. So once we find the LCD, we're going to use this method where we are going to be clearing fractions. So once you identify the LCD, you clear fractions. What do I mean by clearing fractions? Yes, I'm going to multiply both sides by 12. So everyone is going to be multiplied by the LCD, 12 on all sides. So if I have a 12 times 2x over 3 plus 1/2 is equal to 12 times x over 4 minus 9 over 2. I'm going to use that LCD to clear the fraction. So I'm going to multiply the 12 out. I get 24x over 3 plus 12 over 2 is equal to 12x over 4 minus, here, what's 9 times 12? That's 108 over 2. Now I'm going to simplify 24 over 3, that's 8x plus 6 is equal to 3x minus, well, when we divide 108 divided by 2, we get 54. Now I have cleared all my fractions. I'm going to combine my x's. So 8x minus 3x is equal to negative 54 minus 6. Oops. And then this is going to be negative, it's going to be 5x is equal to negative 60. And then I'm going to divide both sides by 5. So divide both sides by 5. X is going to be negative 12. So my solution, so if I do 60 divided by 5, I get 12, negative 12. Now let's see if that's true. We need a substitute or plug in. So we are going to plug it in into the original. So we're saying that x is negative 12. Let's see if that's true. So if x is negative 12, we'll have negative 12. Oops, let's go back. So right now we're going to check. So it's 2 times negative 12 over 3 plus 1/2 is equal to negative 12 over 4 minus 9 over 2. Let's see if that's true. Well, here we're going to get negative 24 over 3. And then plus 1/2 is equal to, well, that's negative 12 over 4 minus 9/2. Well, here I get negative 8 plus 1/2. This is negative 12 and 4 divided by 4 is negative 3. Now, negative 9 over 2, what is that in terms of fractions? That's negative. How many times 9 goes into 2 goes into 9? 4 times 4.5. So then technically, if I combine negative 8 plus 1/2, I should get negative 7.5 if I change that to a decimal. And this is negative 3 minus 4.5. That's negative 7.5 is equal to negative 7.5. Oops. And that is a solution. So they're both equal negative 7.5. So my solution is x equal negative 12. We just verified that. Okay. So we're going to use that method of clearing fractions. And notice here, all of the denominator are equal. I don't have to use that method. Let me emphasize that all the denominators are equal. So when we have a rational equation, if the denominators are the same, then the numerators are the same. So let's write that down. If the denominators, and that's key, if the denominators are all equal, then The numerators are equal. So in this case, all the denominators are equal 3 times p plus 1. So we are only going to focus our eyeballs in the numerator. So I have 5p plus 1 is equal to 3p minus 3 plus 9p minus 3. I'm going to combine 3p and 9p. That's going to give me 12p minus 6 minus 3 minus 3, 5p plus 1. I'm going to bring the 6 over here, the 5 over here. So that's going to be 6 plus 1 is equal to 12p minus 5p. 7 equals 7p. That means that p is 1. And we just solved this equation. So let's see if that's true. Let's substitute p equal 1 into the original. So let's substitute p here. So 5 times 1 plus 1 over 3 times 1 plus 1. On that side of the equation, we get 6 over 6, which is 1 on this side. So this side is 1 when p is 1. Because 5 times 1 is 5 plus 1 is 6, all over 3 times 2. Now we need to look at the other side of the equation. We need to look at this side of the equation. So we have 3 times 1 minus 3 over 3 times 1 plus 1. So on the top, it's going to zero out. 3 minus 3 is 0. Over 3 times 2, that's just going to be 0. So this zeroed out. And so we only have 9 times 1 minus 3 over 3 times 1 plus 1. 1 plus 1. So it's 9 minus 3, that's 6 over 6, which is 1. So we have the left-hand side is equal to the right-hand side, which is, they both equal 1. So we just verified that equation. Looking at number 9, be careful here. Number 1, so this 1 is a 1 over 1 minus 3 over x plus 1 is equal to 3x over x plus 1. So we need to identify the LCD. The LCD is x plus 1. This has x plus 1, this has x plus 1, but not the 1. So I need an x plus 1 here and here. Whatever I do to the top, I do to the bottom. So then I modified just that first one, x plus 1 over x plus 1 is minus 3 over x plus 1 is equal to 3x over x plus 1. Now we go back to 8. All the denominators are equal, then the numerator is equal. Oops. So then I have x plus 1 minus 3 is equal to 3x. I only focus on that numerator because all the denominators are equal. Then I combine 1 and 3, that's x minus 2. Is equal to 3x. Now I bring the 2 over this side and the 3x this side, whichever one you want. Or you could have brought the x over here and subtracting it. So it's negative 2 is equal to 3x minus x. Negative 2 is equal to 2x. So negative 2 is equal to 2x. Divide both sides by 2, I get x equal negative 1. Well, let's see if that's true. So I need to go back to the original equation right here. I'm going to go back to this equation and substitute x equal negative 1. Well, when that happens, if x is equal to negative 1, what happens to my denominators? Negative 1 plus 1, that's zeros. So x cannot equal negative 1. So this is called an extraneous solution. So actually, x equal -1 can't be the answer. Even though we solve for it, it's called an extraneous because x cannot equal 1 because that would make our denominator 0. So that's called an extraneous solution. That means there's no solution here because x cannot equal 1. So that would be no solution because of the domain. The denominator cannot equal 0. Now let's look for question 10 and 11. If we're solving for x, it's already telling you what variable they want to solve for. So you want to isolate the variable. Isolate the variable. So in this case, we want to isolate the x. So I want those x's to be together. I'm going to bring this x to this side and the 7y onto the other side. 2x minus 3xk is equal to 7y. I'm only interested in the x, so I'm going to factor out the x because I'm interested in that variable. I'm left with 2 minus 3k is equal to 7y. Now I'm going to divide both sides by 2 minus 3k. Again, I'm only interested in the x. So x is equal to 7y over 2 minus 3k. And that is your solution. I'm interested in solving for x. Same thing here, but now there's a lot of things involved. I'm going to have to multiply over. So that's 32 minus 8x plus 6p is equal to -5k minus 11xy. So I have an x on this side and a negative on this side. I'm going to bring these two to the other side and the 11 onto this side. So it's going to be positive 11xy minus 8x is equal to negative 5k minus 32 minus 6p. Because I brought the minus 32, I brought the 6p over by subtracting. Now I'm going to, again, I'm interested in solving for x. So that's what they have in common. I need to factor it out. That's why I want those together so then I can pull it out. I'm left with 11y minus 8 is equal to -5k. That was here. Minus 32 minus 6p. And then there's nothing that I can combine. So I'm going to divide it out. And I cannot simplify. So x is equal to -5k minus 32 minus 6p all over 11y minus 8. And that would be my solution. Again, I want to solve for x. That means I want to isolate it. That should be by itself. So I need to put those terms together so then I can factor it out. Let's look at absolute value equations. So if you remember, absolute values, by definition, means distance, the distance away from 0. So just to recall, if we had the absolute value of x is equal to 3, I'm looking at the actual distance is 3. So 3, I can get 3 from +3, and I can get a distance from 3 at -3. So I actually have two answers. I have to consider the positive and the negative. This solution of the output of the absolute value is always greater than 0 or greater than or equal to. So it's always greater, the output. So this number, the answer should always be greater than 0. You can't have negative distance. So to answer this first question, the distance from 0 is 3. That number in the inside, x, can be +3, but also x can be -3. That's the input, that's the inside. The outside, the output, can never be negative. So if I'm looking at these absolute value equations, this is saying that this distance is 9. The total distance from 0, so this is 0, Now it's saying the distance from here to here is 9, but also 9. So my answer, y, can take on the value of 9 and of negative 9. Same thing here. They're saying that the inside, the distance of the inside is 1. So that means that x plus 3, the inside, x plus 3 is 1, and x plus 3 is negative 1. Sorry, the inside. Negative of x plus 3 is also 1. Because it's the distance, positive or negative. So then here, when I solve, well, that's nice because I can subtract both sides. And I get x equal negative 2. When I plug in negative 2 in here, I'm going to get negative 2 plus 3. That's a positive 1. The absolute value of 1 is 1. Now, if I look at the next equation, negative x minus 3 is equal to 1. Bring the 3 over. Negative x equal 4, so that means x is negative 4. So when I plug in negative 4 to check, the absolute value of negative 4 plus 3 is the absolute value of negative 1, which is also 1. So then both of those are your answers, x equal negative 2 and x equal negative 4. So both of those are your answers. So I have to be very careful. I'm always isolating the absolute value. So step 1, you need to isolate the absolute value. Then the right hand side must be positive. Must be greater than or equal to 0. It must be positive. So let's do that. Right now, I need to isolate this absolute value. So I'm going to bring the 3 over by adding 3. So that means the absolute value of 2k plus 1 is equal to 7. That means that the distance away from the inside is 7. It could be the positive or the negative. Not the 7 is negative, or the 7 is positive. So I'm going to have 2k plus 1 equals 7. And negative 2k plus 1 is also 7. So then I'm going to isolate k. And I'm going to check. I'm going to get 2k equals 6. So that means k is 3. And then here, if I distribute this negative, negative 2k minus 1 is equal to 7. Bring the 1 over by adding. It's going to be 2k equal 8. K is equal to negative 4. So I'm going to have to check these solutions. These two solutions, I must check to the original equation. So let's do that. Let's substitute it. So it's going to be 2 times 3 plus 1 minus 3 should be equal to 4. And the absolute value of 2 times negative 4 plus 1 minus 3 is 4. Let's see if that's the case. So here I have 6 plus 1 minus 3, that's 7. The absolute value of 7 minus 3, that's 7 minus 3, that's 4. That's good. Now over here, I have negative 8 plus 1 is minus 3 is equal to 4. This is the absolute value of negative 7, which is also 7. Minus 3, that's 4. So yes, k equal 3, k equal negative 4 is my solution. So I have two solutions for this absolute value equation. Moving on to 5. Well, 5 is again the inside. R plus 6 should be equal to 2r plus 1. And negative r plus 6 should be equal to 2r plus 1. So let's combine like terms. I have a 2r here and an r here. 1 and a 6. So I'm going to bring the r over and the 1 over. So it's going to be 6 minus 1 is equal to 2r minus r. 5 is equal to r. Or going to the other side, distribute the negative. Negative r minus 6 is equal to 2r plus 1. Bring the r over, bring the 1 over. I'm going to get 2r plus r is equal to negative 6 minus 1. So here, minus 6 plus. So 2r, I brought the r onto this side, making it a plus. I brought the 1 over here, making it -1. So it's -6 minus 1. So I get 3r is equal to -7. So r is equal to -7 over 3. So I have to check my solutions. Let's look at the first one. The first one says 5. So it's the absolute value of 5 plus 6. That's the absolute value of 11. Is equal to 2 times 5 plus 1. That's also 11. Now the next one is -7 over 3. So it's -7 over 3 plus 6 should be equal to 2 times -7 over 3 plus 1. So when I do -7 over 3, common denominators of 1, so times 3 times 3, that's -7 plus 18 over 3 is equal to the absolute value of -14 over 3 plus 3 over 3. So that's this looks like 11 over 3 is equal to -11 over 3. Well, the absolute value of 11 over 3 is 11 over 3, and the other one is negative. The absolute value of a -11 over 3 is 11 over 3. So that means that both suffice. That was 5, and it looks like we skipped 4. So let's go back at 4. What did we say about x, the absolute value of x equal -2? What did we say about that? We first want to isolate the absolute value, then the right-hand side must be strictly greater than or equal to 0. What is that right-hand side? -2. -2 is less than or equal to 0. So this is no solution. The absolute value must be equal to a number greater than or equal to 0. It cannot be negative. That way, we can say there's no solution. Let's look at one application problem. When we are doing application problems, we need to read the problem carefully, decide what you want to solve for first. Focus on the facts you know and what you need to find. Identify the unknown. Name the unknown with the variable, write it down. Decide on a variable expression to represent any other unknowns in the problem. Draw a sketch or chart to organize your information. Use the information above to write an equation. Then you want to solve the equation and then check your solution. And then, of course, write the answer in the original problem. Let's look at an example. An investor invests $20,000. This is the principal amount. This is important information. $20,000 received from an insurance and settlement in 2 ways. There's a rate of 6% and there's a rate at 4%. Together, that's key. All together, she makes $1,040 per year in interest, how much she invested at the 4%. So let's look at this. This is going to be actually a system of equations. Why a system of equations? Because I have 2 equations, the altogether equations, the total equation. So that's x plus y is equal to $20,000. It doesn't matter from which investment. And then each of them have different percents. That's the total equations. This is the percentage equation. So one of the percentage is 4%. The other percent is the 6%. We are interested in X only. We are interested in the 4%. So when we have a system of equations like this, we want to solve for one of the variables. And we want to do this carefully. So what I'm going to do is everything should be in terms of one variable. So I'm going to solve for y here. So x plus y is 20,000. So y is going to be equal to, or in this case, I want the x So X is gonna be 20,000 minus Y. So then I'm going to plug that into, so I'm gonna substitute into equation 2. Into the second equation, equation 1, equation 2. So it's gonna be 0.04 times 20,000, because I'm substituting with X, minus Y plus 0.06 Y is equal to 1040. So then if I simplify, if I multiply everything together, I'm going to use my calculator, 0.04 times 20,000. And this should be it's 800. So it's 800 minus 0.04Y plus 0.06Y is 1040. So this will give me the variable for Y. Again, I'm interested in X. So then when I clean this up, it's 800 minus. So if I have 0.06, a positive 0.06 minus 0.04, that's 0.02, 1040. I subtract both sides by 800. I get 0.02y is equal to, if I subtract 1040 minus 800, that's 240. And then if I divide both sides by 0.02, so 240 divided by 0.02, oops, it's 12,000. So Y is $12,000. So if Y is $12,000, so I have the equation X. X is equal to $20,000 minus Y. So X is $20,000 minus $12,000. So X, the amount invested is $8,000. And $8,000 is how much he invested at 4%. And we can check as well by substituting X 8,000 and Y to be 12,000. And we found this using a system of equations. And with that, we finish section 1.6. Thank you, and I'll see you guys in the next recording. Bye-bye.